This is 5 generations of Apple Silicon MacBook Air. And every year, Apple made it faster and faster while leaving a few strange cracks behind. Slow base storage, weird monitor restrictions, and now local AI performance that's a lot more complicated than Apple's marketing makes it sound. The M5 appears to fix almost all of that. But Apple changed one more thing that might matter more to you than the development-related tests that I'm about to show you. Now, just so that we're on the same page, they're all updated to Tahoe now, the latest version as of right now. And what's incredible is that even the old MacBook Air M1 runs Tahoe just fine. Now, I'm not going to be glazing Apple here in this video. They're not sponsoring this. I bought all these myself over the last few years. So I will be pointing out a few cracks here and there, but the M1 is still a very impressive machine, and you will see. Also, I'm not going to be comparing memory sizes because M1, M2, M3 all had a minimum of 8 gigabytes of memory. M4 and M5 now have a minimum of 16. So most of my tests are designed to measure the chip without turning this into an 8 versus 16 comparison. Every repository, trial account, and developer tool adds to your online footprint. Data brokers connect those pieces, they package them up and sell them. Unless information about you floating out there means fewer ways they can target you. Across dozens of countries, you can require data brokers to erase your information. But doing it yourself means finding each broker, navigating its process, and repeating it when your data returns. Incogni sends removal requests automatically and keeps following up. Here, it found 190 total brokers holding my details, and most have already been cleared. And with custom removals, I submit a page exposing my information, and a privacy expert handles the takedown and follow-ups for me. Incogni's data removal processes were actually verified by Deloitte. Now, it can't erase government records or random social posts, but it can address broker listings and eligible pages. There's also a 30-day money-back guarantee, so make your information harder to find with Incogni. Visit incogni.com/AlexZiskind and use my code AlexZiskind for 60% off an annual plan. Link is down below. Now, from the outside, this could be just an M3 or an M2 or an M4, but it's an M5. Apple has apparently decided to keep the same exact chassis. They thought, hey, we did a good job. We're done with that chassis. Good job, Apple. Everything, the chassis, the keyboard, the screen, MagSafe, and physical ports are all unchanged. Even though I really wanted Thunderbolt 5, it still has Thunderbolt 4 on it. And still just 2 ports on the left side. But they gave us Wi-Fi 7. That's the big one. It's supposed to be able to move data twice as fast as old Wi-Fi. There's a new chip in it called the N1. Does it actually enable MLO and 320 megahertz channels? There's also new Bluetooth on there that can tell you how far your devices are. It's not really my thing, but maybe you like that, then there you go. Now, since I'm in a new place, I have a Wi-Fi 7 here and 10G wired network, so I ran iPerf 3 on all these to see how we do. Now, before I did this test, I ran this on the 5 gigahertz network, and the M5, even though it got the highest speed, it was only 625 megabit per second, which is not great. Then I enabled 6 gigahertz, and I got these results. Yeah. Not great. It lands about where the M4 is, and actually a little bit behind the M3. That's nowhere near where Wi-Fi 7 is supposed to be. That's the real deal, and I tried several times. And it turns out that Apple actually limits this feature to 160 megahertz instead of giving it the whole 320. It's kind of a built-in bottleneck. I don't know if it's because it's a special MacBook Air and not a MacBook Pro. TBD. Kind of already have a little bit of a loss. Don't worry, we're gonna make up for it. Quick word on external monitors. I tested the progression in my M4 video. The M1 and the M2 could only drive 1 external display. M3 finally gave us 2, but only with the lid closed. And the M4 fixed it for real. They gave us 2 external displays plus the laptop screen all at once for a total of 3. The M5? Same deal as the M4. 2 external displays plus the built-in display. No third monitor when the lid is closed. But there is one new trick. The M5 can drive both external displays through a single Thunderbolt port, whereas the M4 had to use both ports up. That matters when Apple only gives you 2 ports. Keeping one free, that's a good thing. We're moving in the right direction here. Now, 4 generations, Apple kept making the processor faster and faster, while storage basically stood still. Boom. Wow, the M1 still kicking. Even the M4, the M1 has way better write speeds on that sequential. And by the way, this M1 has 512 gig SSD on it, and those are actually faster than the 256. These are 256 drives with the M2 and the M3. And let's take a look at the M5 here. Wow. Okay, this is in a different league altogether. The sequential is just insane here, and even the random is faster. The M5 fixed the storage problem so aggressively that my external drive is now the slow one. It more than doubles every machine here. Also, the M5 gets rid of the 256 gigabyte model, which is good. I kept running out of space just installing software for testing, so I'd imagine what real people will do. Not that I'm not a real person. I'm a real person, okay? Anyway, they go up to 4 terabytes now, which is a nice welcome change, but that's gonna cost you a little bit. Speedometer. It runs web applications written with different frameworks. It's not literally a JavaScript single-core benchmark, but it is a good measurement of how responsive a complex web browser application would feel on the main thread. And this affects more than just browsing. If you build front-end applications, this is the environment you pretty much stare at all day while you write, you reload, you inspect, you debug, if you're doing web apps, but also if you're using editors that are built on Electron, which if you're using VS Code, yeah. Now, overall, the M5 is 5% over the M4. It's the smallest generational improvement since the M1. M1 to M2, I'm looking over there because that's where my chart is. I'm just setting this place up, so not everything is in the right place yet. M1 to M2 was 22%, M2 to M3 was 14% bump, M3 to M4, 11%. We're getting slower and slower as far as that improvement here in speedometer. But as predicted, it's visible, but it's not huge. However, if you take a look at the overall improvement all the way from M1 to M5, then we're about 60% more. However, this is not the biggest difference when it comes to CPU power on the new M5. The first 3 machines had only 8 cores. The M4 and the M5 have 10 cores. And most of the stuff we're gonna be doing as developers, like building code, compiling code, or running multi-threaded applications, that's gonna use multiple cores. But also the improvement is coming from changed architecture. They're called super cores now in the M5. Well, at least cores 7 through 10 are called super cores. Here's one more test. This is a C++ compiled application, but using only 1 core. And the way it optimizes the code as it's running is it bounces around the available cores, handing things off dynamically from core to core. And there it is, running on the M1, using those performance cores. That's what it looks like on the M2. Also have 8 processor cores too here, and we've got the sort happening on those performance cores, well, on 1 at a time. It's kind of bouncing between those. Same thing here on the M3. On the M4, we have now 10 cores, and also 10 cores on the M5. The result, 2 minutes and 38 seconds, 2 minutes and 42 seconds, a little bit worse on the M2, 2 minutes 57 seconds, better on the M3, 2 minutes 31 seconds, better yet, and finally 2 minutes and 19 seconds on the M5. It's all incremental, but we're getting better and better. And the M5 is about 8% faster than the M4. That's just pure gain since core count didn't change from M4 to M5. Now, just for giggles, the M2 actually came back a little bit slower than the M1. I know that's within the margin of error, but still, that was a bad year, I think. Big picture, M1 to M5 cut single core sort time by about 36%. Now, this is the kind of improvement that you feel everywhere, but it may not be the kind that justifies replacing the M4. There is something else that might. Sorting integers is fun, but developers don't buy new laptops to sort things. This time I'm gonna do an actual build. I used a fixed Llama CPP commit. Yeah, that Llama CPP, the famous machine learning library, or tool, whatever you wanna call it. Llama CPP build, and it's complete. M1, 1 minute 40 seconds to build that. M2, 1 minute 22 seconds. M3, 1 minute 14 seconds, getting faster. M4, 1 minute 3 seconds, and breaking 1 minute 54 seconds on the M5. And it's about 14% faster than the M4. It cuts the M1's time nearly in half. We're talking about real gains here. Every generation showed us better improvements with the multi-core throughput. And this is not just the CPU cores, this is everything. Everything is involved here. The SSD, the CPU cores, the memory, everything. But there is a little bit of concern from people that think that these machines, whoa, that these machines throttle. And last year's M4 did get pretty warm, a lot warmer than the previous models. So the M5, is it gonna get even warmer now? And is it gonna throttle when we throw really hard work at it? I had a handy benchmark. By the way, my benchmarks are available on my GitHub. So I have a handy C++ program. It's a merge sort and it uses all the cores. Yeah, again, it's a sort, I know, but this one is a serious one. It sorts 1 billion integers using all the cores possible and different algorithm. Merge sort, actually it's my favorite sort. I love merge sort, I know. Call me a nerd in the comments. It's fine, I'm used to it. All right, I've got all these set up, doing a sustained test. And of course, I got my old friend here. For those of you that know what this is, it's been a while. Comment down below. It's been a while, old friend. By the way, this is gonna be a loop running merge sort on 1 billion integers and using up all the cores. So I expect the 2 machines that have 10 cores to obviously win, but which one of them is gonna win and which one of them is not gonna throttle, we're about to find out. There they go. And you can see that this is definitely using up all the cores, all those green soldiers marching on. There's the M4, M3, they're all very, very busy right now. M1 also pretty busy. Iteration 1 is done on the M3, M4, and M5. You can see where that dipped down a little bit and kicked right back up for iteration 2. We're doing 5 iterations. And just finished with iteration 1 on the M1 and the M2, all going according to plan. Now, if you watched my video on the M4 last year, you know that this machine got pretty warm. The palm rests are warm. They're not uncomfortable, they're just warm. They're like, it feels like, I don't know, it feels very warm, but it's not like hot. This, it feels about the same. Maybe just a tad bit warmer for the M5. M3 feels warm, M2 feels cooler, and M1 feels the coolest. How did they get the M1 so right? For those of you that are wondering what I'm doing here, this crazy amount of processing requires a lot of power, and in a small body without cooling, it might just have to slow that CPU down in order to keep up and not overheat. Usually in a MacBook Pro, for example, you'd have fans going so it doesn't slow down even under high load like this. But on MacBook Airs, it might slow down. That's why we're pushing it really hard to see what happens. The funny thing is that M1 is actually finishing up iteration 2 while the M2 is still working on finishing up iteration 1. Oh, just started iteration 2. And we have a winner. It's the M5. Finished 5 iterations, 11 minutes and 33 seconds. All the other machines are still working at it. Some machines are on the 3rd iteration. But I do have to wonder between the M3 and the M4, which one of them is gonna come in next. And I am seeing slowdowns. Thanks, old friend. Don't need you anymore. All right, they're finally all done. And this is pretty significant because this represents those long-running processes that developers that build large code bases will face, taken to the 10th power. So it's a little bit extreme on a smaller scale. Let me get into the results, okay? We've got a couple machines here that took a while. That's the M1 and the M2. M1's last iteration took 222 seconds, M2, 226. Not a huge difference there. And if you examine the overall time, the M2 did the whole job slower than the M1. So that's kind of our loser as far as speed goes. But as far as variation, it's actually the winner. It only had a change of 3% from the first iteration to the last. M3 and M4, 195 seconds and 149 seconds. Much better, but they both had a 5% cut in performance from iteration 1 to iteration 5, which means that each iteration took a little bit longer to do because the processor was throttled. The fastest is the M5, of course, with 129 seconds, but it had the largest variance of 6%. It's not much, but it's definitely there. So that means from iteration 1 to iteration 5, it slowed down the most. All right, we have compiled code. Now let's give it some Python and make these machines really suffer. Now, traditionally, I do the Mandelbrot test, which is different than the one we just did. That was C++ compiled. This one is an interpreted test. It's Python. And I know that some of you are Python developers out there. So let's go. Sometimes it's just fun to press them all instead of letting that guy do all the work. This one is also pretty intense because it pegs all the cores completely. I'm expecting these two machines, the M4 and the M5, to win again, but we'll see. Oh, that was really close. M4 and M5 finished. Then this one, the M3 and the M2, and well, finally the M1 at 56 total seconds for that one, 50 seconds for the M2, 43 on the M3, 34, and not that much faster, only 32 seconds, about 2.5 seconds faster on the M5. Now it's time to change gears and talk about AI. Well, before we get into AI, there is the memory issue, right? Because AI uses two components, memory and the GPU. First, it does the processing, and then it uses the memory bandwidth to do the token generation. And we have a test for that. The Stream benchmark, it's a long-lived staple and has been updated to support the M5s. And the M5 copy is 142 gigabytes per second. That's a 26% jump over the M4's 113. What's interesting is that it's almost exactly Apple's claimed 28% increase. And in absolute terms, it's the single biggest generational bandwidth leap in the MacBook Air lineup since the M1. You know why? AI. I'm gonna stop now. AI. We're not done with AI yet because local AI is a thing now and Apple has been really focusing on it. Last time I treated local AI performance as one number, and that kind of missed what M5 this year is actually really good at and what's changed the most. See, every M5 GPU core now contains a neural accelerator. And you might wonder, well, what the heck does that do? Well, it shows up. All right, there we go. And there is the blue marching man, which I call the GPU usage right here. And we've got decode happening already on the M5. Decode here, nice tokens per second right there, almost 30 on the M3. And we're still on the prefill stage on the M1 and on the M2. Oh, M2 is now decoding, and here we go. And there's the blue marching soldiers on the history charts of all these. Okay, wow. This is different. Now, if you're gonna be doing AI, there's only one machine here that really kicks it up a notch. Let's start from over here, shall we? I'll get to that. So this is MLX Quant 3.4b, 4-bit. Yeah, it's a small model, but these are all small machines with very little memory. So you want to fit all your models and all the context that comes with it inside the memory footprint. Some of these have 8 gigs of memory. Yeah, 19.3 tokens per second here on the M1, 26.6 on the M2, 30 tokens per second on the M3. We're getting faster and faster. That's good. It kind of follows that memory bandwidth stream benchmark that we just did. 33.3 tokens per second on the M4, and quite a lot more, 43.9 tokens per second on the M5. What am I excited about then? Well, if you have a keen eye, you might have noticed another number here that's very important. The number I just mentioned is token generation. That's how many tokens per second we're actually putting out. But what about prompt processing? That's the PP number here. 135 tokens per second on the M1, 150 on the M2, 255 on the M3, 284 on the M4. And this number is important because that's the number you're going to actually use when you're having a large prompt. And if you're using this in a coding scenario where you're hooking it up to your code editor, this is the number that's either going to slow you down or speed you up. It's a break it or make it moment. And look at this right here, 1,061 tokens per second on the M5. That is huge. That's 3.7 times the M4, from 284 to 1,061 tokens per second, which almost exactly lines up with Apple's 4 times claim. And from M1 to M5, that's almost 8 times prefill improvement. That is a result of those neural accelerators in the GPU cores. Yes, the memory bandwidth is faster on that, but it's incrementally faster. This is the actual GPU processing power that's going to dramatically improve your AI tasks. Now, the M4 launched at $999 with 16 gigabytes and 256 gigabytes. You know which one is which. The M5 launched at $1,099 with 16 gigabytes and 512 gigabytes. At $1,099, this was easy. You were paying only $100 more and getting twice the storage and dramatically faster SSD, faster CPU, faster GPU, better local AI performance. But Apple raised prices across the Mac and iPad lineup, and the 13-inch M5 Air went from $1,099 to $1,299. Now, Apple stated the reason: memory cost crisis with AI data centers absorbing the global supply of RAM. I don't know how long this is gonna last, but this may be the new normal, as unfortunate as it may be. It is a beast of a machine, but if you don't need that AI performance, check out last year's model. Apple finally fixed the base MacBook Air, but then they added $200 to the price. Now, sometimes there's deals, and if I find any, I'll link to them down below. But the question is no longer whether the M5 is better. Of course it's better, and in some cases, it's a lot better. The question is whether these fixes are worth the gap now between this and the discounted M4. If you already have an M4, keep it. Sure, the M5 has a much faster SSD and more interesting AI architecture, but it does not make the M4 obsolete. If you are lower than that, M3, M2, M1, and you're running out of memory or you're running out of storage, you need multiple external displays, then think about the upgrade. Otherwise, if you're doing ordinary development, probably doesn't demand an upgrade. The M1, still pretty surprising to this day. 2026. And ever since then, Apple has been sealing the cracks one by one. And now that they got to the M5, it seems like they're almost done sealing the cracks, except for the one in your wallet. They made that one a little bit wider. If you want to watch my M4 video for devs, watch that over here. Thanks for watching, and I'll see you next time.